Welcome back, learners, and let's continue with our lesson on exponents. So our focus now is going to be on law number 1, multiplication of powers of the same base. So when we have the first law and we are multiplying the same base, an example of this is when we have a to the exponent m multiplied by a to the exponent n. So we can see that they have the same base and they are being multiplied. So what happens in this case? That means that we are going to keep the base and we are going to add the exponents. So we are going to say a to the exponent m plus n. So we are going to add the exponents. Let's look at an example where we are using numbers. We have here 2 to the exponent 5 multiplied by 2 to the exponent 3. So according to the law, what do you think is going to happen to this calculation? Yes, you are correct. We are going to keep the base and then we are going to add the exponents. So this means that our answer is going to be 2 to the exponent 5 plus 3, which gives us a final answer of 2 to the exponent 8. Another example is if I have 7 to the exponent 6 multiplied by 7 to the exponent 3. So again, the base is the same. We have a base 7 with the first power and a base 7 with the second power, and they are being multiplied. So what does this mean? It means that we are going to add our exponent. We are going to have 7 to the exponent 6 plus 3, and that is going to give us a final answer of 7 to the exponent 9. Let's answer the following questions without the use of a calculator. So using the law that we just found now, 7 to the exponent 8 multiplied by 7 to the exponent 3 will be 7 to the exponent 8 plus 3, which gives us 7 to the exponent 11. Then we have 3 to the exponent 7 multiplied by 3 to the exponent 2. The base is the same, so we are going to add the exponents. This is going to give us an answer of 3 to the exponent 9. Then we have 9 to the exponent 3 multiplied by 9 to the exponent 2, because that means multiply. We are going to do the same thing. We are going to keep the base and we are going to add the exponents, which is going to give us an answer of 9 to the exponent 5. Then our next one is 6 to the exponent 6 multiplied by 6 to the exponent 2, because again, that does mean multiplication. So we are going to keep the base and we are going to add the exponents, which is going to give us an answer of 6 to the exponent 8. Then when we are looking at this one, it is negative 5 to the exponent 4 multiplied by negative 5 to the exponent 2. Our base is the negative 5, and then we are going to add the exponents, and that is going to give us an answer of negative 5 to the exponent 6. Let's move on to our second law. So when we have law number 2, which is division of powers of the same base. So law number 2, division of the same base. If I have a to the exponent m divided by a to the exponent n, what happens to the exponents because I have the same base? So we are going to keep the base and we are going to subtract the exponents. So with multiplication, we were adding the exponents, but now with division, we are going to subtract the exponents. Let's look at an example. I have 2 to the exponent 5 divided by 2 to the exponent 3. What do you think is going to happen to those exponents? We are going to say 2 to the exponent 5 minus 3. And what is 5 minus 3? That leaves us with the exponent of 2. The same thing with my second example. I have 7 to the exponent 5 divided by 7 to the exponent 3. So I am going to keep the base and I am going to say exponent 4 minus 3. This is going to give us 7 to the exponent 1. So let's answer the following questions so that we can see how division of the same base works. I have there 7 to the exponent 9 divided by 7 to the exponent 3. So that is going to be 7 to the exponent 9 minus 3. Our answer is going to be a base 7 and an exponent 6. The next one, we have 9 to the exponent 3 divided by 9 to the exponent 2. So again, we are going to keep the base and we are going to subtract our exponents. So 9 to the exponent 3 minus 2 will give us 9 to the exponent 1. Then we have 6 to the exponent 6 divided by 6 to the exponent 2. That is going to give us 6 to the exponent 6 minus 2, which gives us an answer of 6 to the exponent 4. Then we have negative 5 to the exponent 4 divided by negative 5 to the exponent 2. We are going to keep the base of negative 5 and we are going to say 4 minus 2 with the exponents. That will give us a final answer of negative 5 to the exponent 2. And then our last one there is 256 divided by 64. Now, do you remember that one from the did you know? So we are going to first write these numbers in their exponential form. So 256 is actually 2 multiplied by 128. And this is divided by 64. Now, if we break that up further, that is going to be 2 multiplied by 2 multiplied by 64. Then we are dividing that by 64. Now, we already know from previous examples that 64 can be written as 2 to the exponent 6. So I am going to write that as 2 to the exponent 6 with both 64s, and then we are going to apply our laws. We already learned that when we are multiplying, we are going to add the exponents. So we can just say there that is 2 plus 6. And now that we are dividing by this power here, we are going to subtract our 6, which is going to give us a final answer of what is 2 plus 6, that is 8, and we are going to subtract 6, that is going to leave us with 2. So the answer there is 2 exponent 2. So focusing on our third law now is going to be raising a power to a given exponent. So let's quickly look at that and how it works. So our example here, we have a to the exponent m as our power, and that is raised to the exponent n. So what happens here is that, again, we only have one base, so we are going to write the base as is, but now we are going to multiply the exponents. An example of this is that we have 5 to the exponent 2, and that power is raised to the exponent 2. According to our law 3, we are going to say base 5, and that is going to be 2 multiplied by 2, giving us an answer of 5 to the exponent 4. And our next example is 2 raised to the exponent 3, and then that power is raised to the exponent 2. So what we are going to do is that we are going to write the base and we are going to multiply the exponents. So 3 multiplied by 2, is 2 to the exponent 6. So let's look at an example. We have here 8 to the exponent 2, but we know that 8 can be written as 2 to the exponent 3. Remember, we are simplifying this so that it can be easier for us to calculate these numbers. So if I have 2 to the exponent 3 and that power is raised to the exponent 2, I'm going to keep the base and I am going to say 3 multiplied by 2. So that is going to give us an answer of 2 to the exponent 6. But now, remember, if we are going to take this 8 to the exponent 2 and say this is 8 multiplied by 8. So if we are going to write each of these 8s in exponential form, it is going to be 2 to the exponent 3 multiplied by 2 to the exponent 3. This now takes us back to law number 1, where we have the same base and we are going to add the exponents. That is 2 to the exponent 3 plus 3, and that gives us 2 to the exponent 6, which gives us the same answer, even though we took different routes to get there. Our next example is 49 to the exponent 3. So 49 can be written as 7 squared. And if we use our law number 3 here, we are going to say 7 to the exponent 2 times 3. And that is going to give us 7 to the exponent 6. But again, if we are going to say 49 multiplied by 49 multiplied by 49, because that means we are going to multiply 49 by itself twice, that can be 7 squared multiplied by 7 squared multiplied by 7 squared. And if we are using law number 1, then we can just say this is 7 with exponent 2 plus 2 plus 2, which again gives us an answer of 7 to the exponent 6. Let's go to an ad break quickly, and then we'll see you just now.